Howdy, I'm Blaine Carter. I'm Oracle's developer advocate for open source, and today I'm going to be talking about how you can get started using autonomous transaction processing databases if you're a developer. So a couple things I'm going to do. First up, I'll talk a little bit about how you can get an ATP database, get it up and running, and download your credentials file that you're going to need. And then I will walk through some examples for a couple different languages. Some of these languages I've programmed in more than others, so forgive me if my explanation of the examples might be a little off here and there, but I will do my best. It's actually pretty easy to get started with Oracle's Autonomous Transaction Processing Database, and if you go to here, where's that, right there, which is oracle.com/cloud/free. That looks like this. Oops, let me get in the right spot. That'll get you to this page, and if you sign up here, you can get some cloud services from Oracle that are always free, and that's a pretty good deal, I think. The way you do that is click on the little Start for Free button and go through and populate all the information for creating an account, and then the account will take a few minutes to get set up, and then once it's set up, you'll be ready to create your first ATP database. Now that you've got your account all set up and configured and you've logged into the dashboard, you should see something similar to this. So we're going to go to Autonomous Transaction Processing, create a database. And we're going to jump in here. I'm going to change the compartment to demo. I'll talk a little bit about compartments later on, but I like to do things in different compartments. I'm going to change the display name to Blaine Demo. I'm going to leave the database name alone. That's more of an ID type of a thing. You can change that if you'd like. I'm going to scroll down here. We want it to be a transaction processing database. We want it to be serverless. We do want to set it to always free. With always free, there are some size limitations. However, I believe all of the features for ATP are in there. It's just a size limiting thing. So we're going to tab down here to the credentials field. We're going to add a password for the admin user. So remember with ATP that you're not going to log in as sys or system. You're going to log in as admin. So this is an admin user. And so for that, we want to set a very strong password. And then down here, we'll put the same one. And then we'll make sure that all the password rules line up here in a second. And then it will default to license included, since we're going to set this up as an always free ATP instance. And so once that's all done, you'll hit Create Autonomous Database, and that will take a few minutes to deploy and create everything that you need. And then we'll be ready to try this thing out. All right, now that our ATP database has been provisioned and it's up and ready to go, we need to get the credentials file so we can access the database. With ATP, Oracle does do a little extra strong security, so we are going to need a wallet file. So we're going to come into the dashboard for the ATP instance. This is what should have popped up after it was done provisioning. We're going to click on DB connection. We're going to go to download, and here we're going to give it a password and same password, and we're going to hit download. And then this is going to create a zip file, and I'm going to put it in my demo wallet creds directory here, and I'll hit save there. And then you can see here I've got that file downloaded, and so I'm going to go ahead and extract the file just directly into this directory with the rest where the zip file's at. A bunch of stuff that came with it, all the wallet, key store objects, and the SQLnet.ora and TNSnames.ora. One thing we do need to do as long as we're here is we want to go into the SQLnet directory, and we want to set the wallet location so that it points to where the wallet is, and so that's the directory where the wallet needs to be set. And we'll hit save and close that file, And then that should have our credentials set up and ready to go. Now that our ATP instance has all been provisioned and it's all set up and ready to go, let's jump over and test it. One really easy way to test your connection is to use Oracle SQL Developer Tool. It's a free download. It's a really great tool. If you've never tried it before, you should give it a try. All right, I'm going to come over here in the connections and I'm going to create a new connection. And I'm going to call this one ATP Demo. I'm going to log in as the admin user that we created back when we created the instance. Give it the password. I'm going to save the password because I like to live dangerously. I'm going to change the connection type to use the cloud wallet. Now, if you remember where we saved that zip file before, I'm just going to copy and paste in that location. Notice that it does go all the way down to the .zip. Okay, so once you have identified the wallet you're going to use, the configuration file, that will populate this services directory. And so these are a few TNS names entries that have been created for you automatically. They all mean different things. They'll have different features that come on or off depending on how you need to process your transactions. For your average transaction processing, you should use just the one that ends with TP. You may remember from when we set the database up, this big ugly looking part here, that was what I left the database name as, not the display name, but the actual database name. So if you name it something a little bit nicer, it will look better there. But I'm going to go ahead and select the TP service, and then I'll hit test that out. Success, that gets us to our ATP database. So I'm going to save that and just connect up to it. And then, there we go. While we're in here, I'm going to create a, let me fix this right here real quick. All right, that should be ATP demo and replace all. There we go. All right, so I'm going to, real quick I'm going to create a new schema that we're going to use to test the different things out with. So I'm going to create a new user called ATP Demo and give it this really super top secret password here. So don't memorize that. You can if you want. I'm going to nuke all this when I'm done anyway. So that looks good, and I'm logged in as the admin user. So I'm going to run that. And that's all good. So now we have we've tested our connection to the database, and we've created a new schema that we will use to test things with. All right, I'm going to close all of this up because I won't need to come back to here anymore. All right, we probably ought to test the connection to the new schema that we set up, and so I'm going to test that with a different tool. This time I'm going to use Oracle's SQL CL, which is more of a command line SQL tool. And the way I'm going to run that, to connect to the Oracle ATP instance in order to use the wallet, we need to go into SQL CL with the no log option. So I've got mine set up to just be SQL no log. That gets me into SQL CL without logging into any database. Then we need to set the cloud config parameter to point to where we downloaded that the wallet credentials to, point it to that zip file. So I'm going to enter the command set cloud config and give it the zip file. And then once that is set, I'm going to connect to that new ATP demo user that we created with that super secret password and logging into the TP service. And so once we've done that, you can see down here that we are connected, and we can select I'm in from dual. There we go, I'm in. So that shows that we can still connect from the other tool, and that our new schema that we're going to be using to test all these different services with is up and running. If you'd like to get a copy of all these examples I'm about to do, I'm pulling them from an Oracle Magazine article I wrote a little while ago called Getting Started with Autonomous, that you can find at this URL up there, wherever it's at. I'm not going to read that out. It's kind of a long one, but you can go there and that will get you to, let's turn that off there. That will get you to this article here, which has some of the stuff that I've already covered along with the examples that I'm about to go through. To try and make things a little easier on myself so I don't have to type this information in over and over and over and over again, I'm going to set up a few environment variables that will be used by the different examples. For example, the username, password, the service I'm connecting to, and then in one or two of the examples, it will use a connect string rather than the individual values, so I'll set that up as well. And then since the connections are all going to be using the TNS names, I'm going to set up the TNS admin environment variable to point it to where I extracted those wallet creds. So let's run all of those and get our environment set up. Now, as I mentioned at the beginning, I'm more familiar with some of these languages than other. I'm not really an expert in all of them or any of them. I kind of dabble a bit here and there, but we'll start out with one that I'm most familiar with, which will be Python. So if we open up the Python demo, a couple prerequisites that you'll need to do is you'll of course have to have Python installed, and you'll have to have already completed a pip install of the CX Oracle driver. There's lots and lots of information out there on how to do that, so I will leave that up to you to go find. Just search for CX Oracle, you'll find lots of stuff on that. So I'm going to import CX Oracle. I'm also going to import OS so that we can read the environment variables. And then I'm going to use CX Oracle to open a connection and store that connection in the con variable. And I'm going to pass in the environment variables for user, password, and service. After that, I will create a cursor from that connection, and then I will execute the SQL statement that says select connected to autonomous transaction processing from Python. So pull that out as a string. I'll select that from dual. Then I will fetch the records and loop through and print the rows, then close the cursor and close the connection. So let's change into the Python directory. Let's see if I can spell it right. See, this is why I did the environment variable, so I didn't have to sit and try and type things. And so when I run that, I'm going to type in Python. I like Python 3, so I'll put in Python 3, and we'll run Python demo.py. And that went out and connected to our autonomous database using the environment variables that we set up there. And so you can see there's the string we connected from Python. Time to jump over and we will look at Node. So I'm going to switch into the Node directory, and we will open up the node demo.js that you can see here. Now, one thing I have already done is I have done an npm install of the Oracle DB driver. So once again, there's lots of documentation out there on that. You can look that up. And if you go to that Oracle Magazine link that I showed you earlier, there are lots of links in there to help you get to the places where you can find these things. So you don't have to just go hunt for them. But anyway, we'll start out with requiring the Oracle driver, because we're going to need the Oracle driver. And then we will use that to get a connection to our database using the environment variables for user, password, and service. Remember, that's our TP service. Once we have that, we are going to accept that connection. This is a callback function of there. We're going to take that connection that's created and check for errors, and then we're going to connection.execute, and we're going to execute a similar query to what we did with the other example. We're going to select connected to ATP processing to ATP from Node.js, and we'll select that from dual. And then if there are no errors, we will console log out the results. So here I'm going to type in node and node demo.js, and I'll run that. And that's what your output should look like. So that shows you that we brought back our record, and we have our string that we connected to ATP from Node.js. All right, time for one of the languages that I have dabbled with, but I'm not super familiar with. So we will try Ruby. Once again, I've already got the driver set up and ready to go. The driver I'm using is OCI 8, and so I'll require that at the beginning here. And we will create a connection by doing OCI 8 new, pass it in the user, password, and service. The statement we're using is pretty much the same as in the other examples, only we're selecting from Ruby. And then we'll create a cursor when we parse the statement with using the connection. So connection.parse, pass it in the statement. Once we have our cursor, we will execute the cursor and then fetch from the cursor. And if there were more than one rows, we'd loop through them and print out the values for each of the rows, which there will only be one. So I'm going to change into the Ruby directory, and then here I'm going to type in Ruby demo and run that. Okay, so the NLS lang, that's something I forgot to set up in my environment. However, you can see that the Blaine mess up aside, you can see that even without that, we did get our connection to connect to the autonomous transaction processing from Ruby. All right, time to go with the language that I have the least experience with. That would be, of course, Golang, and this would probably be the most difficult thing I have done so far with Go. I am still using Go. So I apologize if I explain some of these things wrong. I kind of cherry-picked bits and pieces of this to put the example together from different places. So here we go. We will start out with creating a package, and then I will import the Go Oracle driver, which I, of course, have already pre-installed, and that's set up ready to go. We're going to create a function called main. We're going to get the environment variable for the connect string. If you remember, in the beginning, I talked about how I had some user password settings and one that uses a connect string. This is the one that uses a connect string instead of the individual items. And then I will use SQL.open, tell it to use Go Oracle, and use that connect string to open a database connection, which we'll store here in the DB variable. And then a little bit of error checking. And after that, we will use db.queryRow and pass in a very similar query to what we did from the rest of it, only processing from Go. Store that in the row object, and then a little bit of error checking. And down here, we will print out from the string column. Oh, I missed that part. Roast.scan parses out the value from the query. And then if there was an error, then that would print up the panic error, or it's called panic error. Like I said, I'm not an expert at Go yet. I have a vague idea what most of this does. But should there be no errors, then we'll make it down to the print statement where we will print out the string column. And so before we go, I need to switch into the Go directory. And then once we're in there, we need to go build go demo.go, and that should build can basically compile the application. Then we can /go demo, and you can see there we connected to the autonomous transaction processing database from Go. So once again, I made the Go thing work, and it's not that I'm against Go. It's a very interesting language. I just haven't had time to dig into it, and I will be doing more stuff with Go in the future. But for now, at least I can connect to my database. So you may have noticed a fairly common theme throughout all the different examples through the different languages. Basically, the way that we're connecting is if you can connect to the database with the TNS names entry, then you should be able to connect through it using Autonomous as long as you set up the wallet as we did at the beginning. So for example, here are a few other languages listed here with their drivers that you could try out. Now I haven't tried most of these, so I can't tell you for sure that they work or not, but basically if the driver for the language you're using lets you connect with TNS names, it ought to work fairly similar to the way that the rest of these examples worked. You can go to the Oracle Magazine article that I linked earlier on, and all the code examples that I've used should be in that article, along with a whole bunch of helpful links to get you to the places where you can find some more information. But anyway, that should be a fairly good example of how to connect using, what do we do, Python, Node, Go, and Ruby. For this next section, I'm going to walk through another article that I have up on Oracle Magazine, and you can find it there at this address that's up on the screen. I'll leave that up there for just a second. It's kind of a long one, but this one will be walking through kind of going in the opposite direction from what we just did. So we are going to look at how to create an ATP instance using Python. And so basically the Python SDK, I'll use the Python SDK, which uses the OCI, CLI, so Oracle Cloud Interface, command line interface. Those are integrated together, so you can write a Python method that will create or terminate a database and even get the zip file. So I will be walking through the code examples in this article to show you how that works, and let's get going. All right, in order for this to work, you will need to have some prerequisites before you get too far into it. First up, you'll have to be able to create an Oracle Autonomous Processing instance, which if you followed through with the previous section of this talk, you've already done that. And basically log into the Oracle Cloud dashboard and create an instance from there so that you know your user has access to that functionality. After that, you will need to install and configure the command line interface for the Oracle Cloud infrastructure, where if you go to the article, you can see right here there's a link that will get you to those instructions, and you'll need to get that installed and configured. And they'll have a little section on there that'll walk you through a quick test to make sure that that's all working. So once you're sure that that's working, then the last thing you're going to need, since this is a Python example, you will need to have Python installed and at least a basic understanding of Python programming, or at the very least the ability to copy and paste my awesome code, because it will work every time, except for those times where maybe it doesn't. But either way, you should be able to get it working. Python 2.7 and Python 3.5 are both supported. Of course, I like Python 3, so that's what I'll be using for the examples. And I'm running on Linux, so some of the commands that I use might be different for your operating system. If you're using Windows or something like that, you might have to modify some of the commands. I've become a fan of the Python virtual environment functionality, and so I'm going to be using that for the examples. And so I'll walk you through real quick how to get everything installed and ready to go, and then we'll drop off the article and actually go over and just start looking at some code. So to start with, we need to make sure we have a directory to work in, and so I'm going to create a directory called OCI Python SDK example, and then I'll drop into that directory. And then you should have, for this part, you should have the Python virtual environment installed. So if you're new to Python, you can go back to the article and follow that link. But basically on Linux, it's fairly simple. You just do a Python -m pip install of virtual env, and then you do a Python -m venv, which is calling virtual environment, and then you give it the directory that you want to put the Python virtual environment stuff into. And so I'm going to call mine env. So this will create that new env directory and put everything it needs in there. There's a bunch of scripts and whatnot in there. And so on Linux, to activate that, you'll call source, and then you'll call env bin activate, which will set up your path and all the variables and whatnot. And to test that, you can say which Python, and when you do that, it should point you to that env bin Python directory that was created up here. So if you do a which Python and you see something similar to this and it's pointing where you expect it to, then that means you have successfully created a Python virtual environment. All right, so the last thing that we need to do setup wise is to do a pip install of OCI. And so now at this point we're working inside of a Python virtual environment, which makes it safe to just run pip install without having to worry about maybe stepping on the toes of some other module or some other application that you've been working on. So at this point we're nice and safe. So pip install OCI will install the Python SDK that works with the OCI command line interface. And then the way that you can test that this works, you might want to go to the article for this part. If you want to copy and paste code, keep the article handy and you can just copy and paste the code as you go. But here you'll see if you type Python 3, that'll get you into the Python, I can't remember what they call it, the Python shell. I'll call it the Python shell. And then you'll start out, you'll do an import OCI, which you just pip installed up there. And then the first thing that you'll want to do is when you installed OCI, the CLI previously as one of the prerequisites, you created a config file. And so you're going to tell the Python SDK, the OCI call, where that config file is. And so we're going to tell OCI that we want to load the config from the file. And here's where we can find the file. And inside that file, you might have different profiles set up, but we just want the default profile. And that'll bring in the configuration that you set up in the previous step. All right, and then we want to create the service client. So we're going to create a variable called identity, and we're going to do OCI identity client and pass it in that config, which will get us the identity object. And finally, we are going to, from that identity, which is basically that's saying whom I logged into OCI as. Think of it that way. And so from that, we're going to get the user by calling identity get user, once again passing in the config that we created up here with just the username or the user object key. There we go. That's the word I'm looking for. And then .data. So basically we're saying go get the data from this object and then print it out on the screen. Once you do that, you should see something similar to this. Big long bunch of data that will probably come in handy at different points in time. But for starters, you can down here, you can see there's my email. There's the time that it was created. This would be actually a lot longer here. I've kind of truncated this so I don't splash my ID across the interwebs. But there'll be a big long number here. It's a big GUID that identifies my user. So if you do get something like this, then your OCI CLI is set up correctly and you've installed the Python SDK correctly and you are ready to go. So you can just type in quit, open, close, paren, and that will get you out of the Python shell. If you did receive an error message, then you want to go back and check your CLI configuration, make sure that's installed correctly and rerun the tests over there. Just make sure that's all set up correctly. And that's usually the only problem that I've run across as I've been playing with this. All right, and so I had mentioned previously that I like to work inside of compartments when I'm working in the Oracle Cloud. Compartment is just a fancy way of saying here's Blaine's little area that I can do whatever I want in, and if I create a database named Blaine, I'm not going to step on the toes of some other Blaine who might have created one in root. So I create a compartment and use that compartment throughout. And if you remember, when we created the database, I had already had a demo compartment created. And so what you'll want to do is go back into the cloud dashboard and expand the menu. And you're going to look for identity in the menu and then click on compartments. Look in the list of compartments, and on there you'll find the compartment that you want to use for the rest of the examples. Excuse me. And when you click on that, you'll see a field that says OCI value. I'm not going to go through all that because that would expose my OCI value, so that's why I'm just kind of showing you this last little bit of the article before we get over and do some real stuff. And then click on the OCID value, save that off, so copy it when it pops up, and then drop out to the shell that you're going to be working in and create an environment variable for that OCI value. And then from now on, we will reference this environment variable whenever we need to call that compartment ID. All right, so like it says here, the example code's all going to look for this environment variable. All right, so let's drop out of the article and we'll get over to looking at some code. Just to make sure that I have configured my OCI correctly, I'm going to run through that little test example that I have on the blog just to show you how it works. And so to start with, I'm going to fire off Python 3 to get into the Python shell or terminal or whatever it's called. I'm not really good with names. I'm going to import OCI. I'm going to run the config equals and load the config from my default config file. Then I'm going to go get the identity using the identity client, and then from there I'm going to get the user from the identity, and then rather than print out that great big example that I have in the Oracle Magazine article, I'm just going to print out the user email just to show that that's working. So there's my email coming out, and then I'll quit to have that done. So it looks like mine is thankfully configured correctly. So I've created a utility module that has some functions in there that I plan to use, where I can call this method to create an ATP database, this one to delete the ATP database, and then when it's all done to download the wallet. Well, obviously not after I delete it. So switch up that order a little bit. We'll start with the create method here, and it accepts a DB client object and an ATP details object, and so they kind of look like this, and I'll get into this a little bit more when I actually make the call to the method. But the DB client is called using OCI database client, and passing it in that config object that I talked about earlier that we loaded from the OCI CLI config settings. And so you call this and it creates a DB client, which we can then use to make calls to the interface. The ATP details object, this is going to be the details for the ATP instance that we're going to create. So we'll pass in an admin password. We're going to use that compartment ID that I talked about. We'll give the database a name. That's going to be the name that's used in things like in the TNS names. Remember, I didn't change mine, so it had that really funky looking number. It's kind of a date number. And then the display name, that's the pretty name that everybody sees, and a CPU core count, and the storage size, and finally the licensing model. So that's what the object that's being passed into ATP details looks like, and I'll show you how that's fleshed out here in just a second. But we're going to call DB client, which is passed in there. In that, it has a method called create autonomous database, and then we're going to pass that the autonomous database details, which is this object here. So a fairly simple method that does that. Once that's done and it comes back with the ATP response, we're going to get in the data. So it's response. It has a data object. The data object has an ID. We're going to store that ID for use later on. Like, for example, down here, we'll use that to get the wallet for that particular ATP instance. And then we will set up an environment variable called current ATP ID. That way we don't have to store this in the Python and pass it back and forth. We can just get it out of the environment. So we'll store that there, and then just to make it nice and pretty, we'll print out a couple statements saying that we've created the database and that we have created the or stored the ATP ID. And then we will return the ATP ID to wherever it was called from. So that's what we'll use to actually go through and create the database instance. Once we're done with it, we could call this delete ATP method here, once again passing in the DB client and just the ATP ID. So that would be the ATP ID that we stored here in the environment variable or return to wherever. And then this is a really simple call. It's just DB client delete autonomous database ATP ID. Now, do take note, This means terminate the database. There is no undo on this method. So when you call this functionality, it's gone. It's not going to, you're not going to be able to undo this. So I probably won't include this in the final running example, but we will have it for if we need to use it. And then finally, if you remember, in order to access the ATP database, we do need to get a wallet. So we've got a get wallet method here, once again passing in the DB client, the ID for the instance we want to get the wallet from. We're going to give it a password. This is the password that's going to be on the zip file. Remember in the last example we downloaded the zip file and we had to give it a decent password. This is that password. Then here we're going to give it a file name, and this can be a directory / file name, but basically this is just going to be the file name, so Blaine's cool wallet.zip, something along those lines. And so the way we get the wallet is we call OCI database models, and we say generate the autonomous database wallet details, and that will create the wallet here, the wallet object. So similar to when we did the ATP details up here, this is going to be the wallet details. And so we're going to assign a password to that details object, and then we're going to call DB client generate autonomous wallet, autonomous database wallet, and store that wallet in this wallet response. To pass into that, we're going to give it the ID for the database and the details for the wallet. So if you remember the details that we used up here, this is also going to be the details, similar type of details that describes how to build the wallet down here. And so when that's all done, we're going to take that wallet response here, and we're going to create a new file called file name, and then just kind of loop through the wallet response data and write that data off to the file name, and then this file will of course be saved as a zip file. And then just for make it pretty, we're going to print out wallet downloaded, and then as a warning, make sure you keep this file secure because it can be used to access your database. In fact, that should just say file and not file name, so we'll fix that. So keep this file secure. It can be used to access your database. And so that is the utility helper package that we're going to use in the next section. Now that we have the OCI ATP.py module put together that has our helper functions, let's look at one possible way to use those functions. So I've added a new module here called ATP_example.py, and with this I'm going to call a couple of the methods from the helper module that we put together. So let's get started up here at the top. You can see I'm importing OCI, so we'll have access to the OCI interface functions, and I'm importing OS because we're going to use some environment variables like we talked about before. And then of course I want to import the OCI ATP module so we can get access to the functions that we used. I'm going to start off with creating a config object that is just going to be OCI config from file, and that will default to the default config that we've talked about before. I will come back to this section here. This is used later on, but I'll come back to that. So I'm not skipping over anything too important here. Okay, so we are going to set this up so we can just run the module from the command line. And the first thing we want to do is we're going to create our DB client. This is that DB client that in the previous module we were passing things in using this, or passing this object in that we use this to access the config or the OCI functionality. And we're going to set that to be OCI.database.database_client and give it that config that we defined up above. So at this point now we have a DB client that we can use to do all kinds of fun and or dangerous things depending on how you misuse it. Remember, you have at this point you should have everything set up, and so when you run things they're going to happen on your cloud account. So keep that in mind. All right, so we want to create an ATP instance to begin with. So we want to set up the details object for that new ATP instance. So we're going to say ATP details equals OCI database models create autonomous database details. And this will just create a blank details object that we will populate down here. So first up, we want to give it a password, and here's a hard super secret password to remember. Please, if you're copying my code off of the article or typing it in out of the video, which is far more hard, remember to change this password to something good, better than what I have here, because this will be the password for your admin user for the database. We're going to use the compartment ID that we talked about before that I've stored in an environment variable, because I like to keep all of my things grouped into different compartments. That way when I'm working on a demo like this, it doesn't step on something that I might actually be running for some kind of production use. And so keep everything grouped up into a compartment. If I haven't defined this environment variable, then we will just get the config tenants, or I'll get the tenancy from the config settings that we imported up there. And what this will do is it will set the compartment to the root compartment. Once again, if everybody is sharing a cloud account and they're all using the root compartment, you might have conflicts every now and then, and not just the programming type. So anyway, I highly advise using compartments. I will try and stop harping on that for now. All right, next up, we want to give the database a name. If you remember when we set up our database before, it had that name that was DB followed by a big long number. If you give this a name here, make it something more readable, more useful, and this will be the name of that database going forward. Keep in mind, this will also be the name that pops up in your TNS names file. If you remember when we did the SQL developer step, and I selected the DB big long number underscore TP service out of the TNS names file. Instead, this one is going to be Py SDK ATP temp underscore TP. So that's what will be used for those TNS names and in other places. So try not to make it too confusing. And then for a pretty display name, for like when you're in the dashboard and you're looking up trying to figure out which database is which, give this a meaningful name so you can identify the database that you are creating. All right, next up, CPU core count. We're going to get one CPU core. We're going to give it a 1 terabyte limit. And then for the licensing model, I'm going to select the BYOL license, so bring my own license. And then with the details defined, I'm going to take that details object and the DB client that I created and pass those into my little helper module and call the OCI ATP create ATP method, passing in those two values. That will actually go out and provision an ATP database right at this point in the application. And as soon as that starts provisioning, it'll have an ID assigned to it. And then if you remember, that method passes back the ID, which we'll store in this variable here. So at this point, you could write just a method that does just this amount. And when you call that method, it creates a database. Of course, you could have put the details in the method in the other module and done the same thing over there. So we don't want to stop at this point. However, I also can't, I don't want to put a pause here and then have to go check in the dashboard to see when it's done, when it's available, and wait for the provisioning. So I'm going to use this little OCI wait method here that's really nice. So what I'm going to do here is I'm going to say OCI wait until. Now the wait until method will take the DB client just like normal, and then instead of just the ID, it wants the full autonomous database information object. So I'm going to use the DB client to get that autonomous database object by the ID. So I'm going to pass in the client and the database object that we're interested in interacting with. And so that tells it which database we want to wait for. And then what we're waiting for is we're going to wait until the lifecycle state equals available. So it's basically going to fire this off, and every so often it's going to check to see if the lifecycle state is available once my database is up and running. Now, it is not going to always be at a fixed interval. Different things will affect on how long it takes between attempts to check the status. However, I would like it to check at no more than 60 seconds. So every 60 seconds, if it hasn't made a call, this max interval will tell it go ahead and make the call. And I don't want this to sit and run for 200 years, so I can put a max wait in seconds to say if it's been more than 6 hours, which is what 21600 comes out to be. I know I checked, but I'll tell it if it's been 6 hours, give up, it's not coming back. You could set this shorter, whatever your patience level is. And then the cool little part here is every time it does a check, if you've created a wait callback function, then it will fire off this little function and pass in a couple values from the current check. So that's the part we skipped over up top here. That's this little function, module, or method. Yeah, got to get my terminology better, better, gooder words. But it will fire off this wait callback module, or method. See, I still did it wrong. And I'm using a global variable called ATP status that I have initialized to be none. And then what I'm going to do is I'm going to check that status. And when this is called from the wait until, it's going to pass in this results object. And so in the results object, I can check the data and check the current lifecycle state, which is what we were checking for down there. And if that's equal to whatever we stored last, which the first call it's not going to be, because the first time this runs, it's going to show up as provisioning. So it's going to say, nope, it's not none. So we'll change this to be provisioning, and then we will print that new change out to the console. However, the next check, unless it is really, really, really fast, which hopefully we'll at least get one dot in the example, it will say, yep, it's still provisioning, still provisioning. So every time it calls still provisioning, it's just going to print a dot on the screen. So what we should see down here in the terminal when we run this is it'll say provisioning, dot, 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 and then it will go up until, if something else happens, so for example, if there was a state it went into error or something, then it would go dot error. And then as long as it stayed in error, it would go dot, 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 dot. At that point, you'd probably want to stop it and go figure out why there was an error. But hopefully, it'll just go provisioning, dot, dot, dot. Once this becomes available, it does not call the wait callback again. It just says, hey, we're where we're supposed to be, move on, which is why I print available here just to make it look pretty in the output. So provisioning, dot, 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 available. And so that will print that out. And now the reason I wanted to have the wait until section in here is I can't download the wallet until the database has been provisioned and is up and running. So this will pause, and then I can go get the wallet. So remember when I created the wallet method, I accepted in two values. One of those was going to be the wallet password. And so here's my super secret wallet password. Once again, you want to change this password if you're copying my code for your example. This is not a good password. Change that to be something useful, because this wallet will, the zip file that you're downloading can be used to access your database. So remember, change that to be a good password. The other value we wanted to pass in was the file name. Now I could set this up with a directory / file name. I'm just going to write it off to the same directory I'm working in. And what I'm going to do is I'm going to go back to this details object, and I'm going to get that DB name that I put there, and I'm going to make it DB name _ wallet.zip. Now, yeah, I could have just typed that in here, but I like to link my things together, so next time I make a database, I just have to change this information and not that. And potentially I could just set it up to where I can just pass in an ATP details object and not have to set this. All kinds of things you can do. I tend to do that. I get easily distracted and I start going, ooh, I could do this, and ooh, I could do that, and then pretty soon I'm off in the weeds. Focus back in. Anyway, so we've got a wallet password and where we want to put the zip file. So once again, we're going to call that OCI ATP module. See, I got the word right that time. And in there, we're going to call the get wallet method, pass it in once again the DB client. the ATP ID so we know which wallet or which database to get the wallet from, and of course the password and where we want to store the wallet. Now, I'm going to fire this off in just a second, but before I do, I want to show you that nothing up my sleeve. This is the instance that we were looking at before. I'm in the demo compartment. There is the always free is awesome. There's the always free ATP instance that I created earlier. If you remember, there's the DB big long name that I used before, and that's the only one there. So from here, I'm going to go ahead and execute this code. All right, to call it, I'm going to call Python 3, and I called it ATP underscore example dot py. So we'll fire that off, and it instantly created the database, and now it's doing that provisioning oh, I did not, let me undo that. Okay, so sorry, I forgot to switch screens. So what you missed on that is I called Python 3 ATP example. It outputted this, it's creating the autonomous database, and it gave a few of the IDs that we need to use, and now it's doing that provisioning dot thing. And so let me put the database back up. We'll refresh. Oh, I didn't even need to refresh it. Auto refreshed for me. I love when functionality works that way. But here's the new one that we made. There's the name that we defined in the ATP details, and the status is, or the state is provisioning. And so this will go along, and I'll just kind of let this ride until it finishes, and then I will edit the video to speed up the time, because sometimes it does take a few minutes to provision. Let me jump back to, turn that on so we can watch the little dots in case you're like me and you think that's fun. I kind of like watching little dots. So maybe what I'll do is, instead, I think I will just pause the video at this point, and then I'll just reactivate it once it is available. I'm not pulling any tricks. This is just the code that's running. All right, I'll be back in just a minute. All right, looks like it came back while I was checking my email on my phone. So let's look here. You can see that it went provisioning ... available. So somewhere in there I have an extra print, so they may have changed it so that it does run the wait callback one last time. Either way, I'll have to fix that code, but you can see that it was available, and then the wallet was downloaded, and we printed this out, keep this file secure. It can be used to access your database, and you can see that wallet file right there. And so we have that up and running. So let's once more look at the FTP, the ATP instance, and you can see here that that Python SDK ATP example is up and running, and it is available, and we have the zip file. So that is an example of how you can use the Python SDK with the OCI interface to programmatically create a new ATP instance in your cloud account. Let's recap what we've done here. So we started out by going through the Getting Started with Autonomous article that's up on the Oracle magazine, and the link for that is right above the blue box. You can get there, should find all the code examples. What we did there is we walked through how to create an Oracle always free cloud account. Then we created an ATP instance. We downloaded the zip file. We used that zip file to connect through TNS names with Python, Node, Ruby, and Go. And once all that was working, we switched over to the other, let's see, let me get the right one up here on the screen, switched over to the article for developers to create an autonomous database using the Python SDK. And through there we talked about how to install the Python SDK a little bit, and then we walked through how to create a database and how to delete a database. We didn't actually run that one because I think I'm going to use that database a little bit. However, if you feel like you need to, you just call it, pass in the ID, and it should delete the database just like the other functions worked. And then we also programmatically downloaded the zip file. So that's kind of a lot of material stuffed in a little bit of time, and you can find the code examples on the 2 links that are up on, let's see, there we go, on that side of the screen, over there. Sorry, the camera effect sometimes messes me up. The mirror effect sometimes messes me up. But anyway, you can find the links to those 2 articles there with all of the code examples, and if you run into problems, reach out to me on Twitter or on, even send me an email, and I will do my best to get back to you and help you out. So once again, my name is Blaine Carter, and thank you for spending your time with me.